Hi students, this will be our last lesson in this unit, Parallel Lines and Algebra. We will be creating equations to solve based off the angle pairs that are formed by transversals and parallel lines. First, we will review what type of angle pairs will make what type of equations. So we'll review the relationships. So first off, when parallel lines are cut by a transversal, which pairs of angles are congruent? Congruent means that they are equal in measure. So if you look at this picture that I drew on the right, this is what we learned in our last lesson. When we have parallel lines crossed by a transversal, the angles, there are 4 pairs of angles that are congruent, and there are another 4 pair of angles that are also congruent. So in my picture, you can see all of the pink angles are congruent and all of the blue angles are congruent. So those type of angle pairs might be like this angle and this angle. Those would be alternate interior angles. Or this angle and this angle. Those would be alternate exterior angles. Or we also have like this angle and this angle corresponding angles. So all of those type of angle pairs are the ones that make congruent angles. So let's go ahead and write those down. So those were alternate interior, alternate exterior, and corresponding. When we have parallel lines cut by a transversal, the angle pairs that are supplementary or that add up to 180 are all of your same side interior or same side exterior. So for example, this angle and this angle, these two angles are same side interior, or like this angle and this angle, these are same side exterior. Notice that the 2 angles that I picked in each of those cases were different colors, which means they're going to add up to 180. So those type of angle pairs were same side interior and same side exterior. Regardless of whether we had parallel lines in a transversal, the angle pairs that are always congruent that we learned about before this unit were vertical angles. So vertical angles would be like this angle and this angle, these 2 orange angles, or these 2 green angles right here. They're across from each other and they have the same measure. The angle pairs that were supplementary, regardless of whether we had parallel lines in a transversal, were if they had 2 different colors. So if you look at like a green and an orange, those are supplementary. That would be a linear pair. Or this green one and this orange one, that would make a linear pair. There are 4 pairs of linear pairs at every intersection. So in total, we've got 7 different types of angle pairs. So on all of these examples, we're going to look and see what do we have expressions for? What type of angle pair does that make? And based off that, are we going to have a supplementary type of equation to make where they add up to 180? Or are we going to have a congruent type of equation to make where they are equal to each other? So this part is also a little bit of a review. You got to get really good at this before you can start making the equations. So for each type of angle pair listed, we're going to tell whether they are or what type of angle pair they are and whether they are congruent or supplementary. So A has angle 1 and angle 3. Those are both in the same position of each intersection. They're in the upper left, so that means they are corresponding. In corresponding, I always remember because it starts with a C, that means those angles are going to be congruent, and you can just use the symbol for that. All right. Next, angle 3 and angle 6. And I'm going to use some different colors here. So angle 3 and angle 6, those are alternate interior angles. They are on different sides of the transversal, and they're both in the interior. They're between those 2 parallel lines. And I can see they're parallel by the little arrows right here and here. Alternate interior and alternate exterior will also always be congruent. All right, now we have Angles 4 and 5. Here's 4, here's 5. Those are on the exterior, but they're also alternate, so they're alternate exterior. And just like alternate interior, they are also going to be congruent. All right, let's look at angles 2 and 3. 2 and 3, now these are on the same side of the transversal, and they're between the two parallel lines, so they're going to be same side interior. And any of the same side ones, they start with S, they're always going to be supplementary. They're going to add up to 180. So let's take a look now at angles 1 and 6. 1 and 6. These belong to the same intersection. So when they belong to the same intersection, they're either linear pair or vertical. And these are vertical angles. And what we need to remember is vertical angles are always going to be congruent. They're going to be equal in measure. And then let's see, I need another color. Let's do this color. Angle 1 and angle 4, these are same side of the transversal, but they're on the exterior. They're outside of the parallel lines. So these are same side exterior. And just like same side interior, if they start with an S, same side, then they are also going to be supplementary. They're going to add up to 180. So you need to be able to identify the type of angle pair and whether they're congruent or supplementary. And then we are ready to try some examples. So in the examples, it says in the directions that lines L and M are parallel. That's important to remember because these relationships aren't necessarily going to hold true if they're not parallel. The only ones that hold true are the linear pair and vertical angles. But those are regardless of whether we have transversals or not. So the alternate interior, exterior, same side interior, exterior, or corresponding are only going to be congruent or supplementary if those two lines are parallel. All right, we have an expression for this angle and this angle. They are between lines L and M, so they're on the interior, but since they're on different sides of this transversal, they are alternate interior. And feel free to abbreviate. Alternate interior, these are going to be congruent. So if they're congruent, you're going to set those two expressions equal to each other. So 2x minus 10 equals 3x minus 40. I think it says 3x. Might need to erase some things. I think it says 3x. Let me erase that. Yes, it's 3x. Okay, just checking. All right, so here's our equation. Now we're going to solve. I like to move all my x's. I'm going to move them to the right, so I'm going to subtract 2x from both sides. Negative 10 equals 3x minus 2x is 1x, or x, minus 40. And now I'm going to move my constants, that minus 40, to the left by adding it to both sides. These go away. Negative 10 plus 40, I'm going to drop down here to the side, is 30, and that's equal to x. So there's my value of x. Now I could go a step further and plug it into any either of those angle measures and find their measures, and then from there I can find any other angle measure. All right, again, for all these examples, L and M are parallel. I've got an expression for this guy and for this guy, and those are right next to each other. So those are going to make a linear pair. So those are going to add up to 180. So they're from the same intersection. It doesn't even have anything to do with transversals. They are a linear pair. Okay, the line that they both form is right here. Together they add up to 180, or are supplementary. So the way we're going to create this type of equation is we're going to add them and have it equal 180. Let me erase some of this. So here we go. I'm going to do it down at the bottom so we have more room. So 3x minus 40 plus 2x plus 10 equals 180. I'm going to combine like terms. 3x plus 2x is going to make 5x. And then negative 40 plus 10 is going to make negative 30. And that equals 180. I'm going to move my constants to the right because my variables are all on the left. So I'm going to add 30 to both sides. So 5x equals 210. And then we're going to divide both sides by 5. So x equals 42, I believe, if I did that right. All right, so there's that example. All right, example 4, remember lines L and M are parallel. I have an expression now for this guy, and those are both on the interior and they're on the same side of the transversal. So they're going to be same side, interior. And remember all of the same side ones, because they start with S, that means they are supplementary. So that means my two expressions are going to add up to make 180. Let me erase that. All right, so here we go. So I'll do it down at the bottom again. So 5x minus 32 plus x plus 8 equals 180. And if you want to practice solving these equations, you can pause it and solve them yourself and then press play and see how you did. Let's combine 5x and 1x to make 6x. These two guys. And then negative 32 plus 8 is negative 24, I believe, yeah, equals 180. All right, so then we will move our constants to one side by adding 24 to both sides. I'm going to move them to the right. So 6x equals 204. And then we'll divide both sides by 6. And x will equal 34. All right, we're almost done. We've got a couple more. So this picture looks a little different. L and M kind of stop at the line. So what you can do is you can kind of extend those lines just so the picture looks a little bit better, and I can even extend my transversal. Remember, L and M are parallel. Okay, so this also looks a little weird because our transversal is going horizontally. So if you were to turn your head to the left a little bit, it might look more like what you're used to, where these are my parallel lines, okay? All right, so what we've got here, we've got an expression for this angle and this angle. And one is interior, one is exterior. Okay, whenever you have that, that means the only option it could be is corresponding, but they'd have to be in the same position at each intersection, which these aren't. So this doesn't necessarily make an angle pair. So we can still figure out the relationships though. So here's what I want to do. I want you to remember the picture that I drew the other day. Whenever you have parallel lines with a transversal, all of the obtuse looking angles are going to be congruent. And then all of the acute looking angles are going to be congruent. Okay? So what I have is I've got this green angle and this purple angle. So because they're different colors, that means they're going to be supplementary. They're going to add up to 180. So we can still have a relationship even though there's not a special name for that angle pair. So I want to add up these two expressions, 3x minus 40 plus x, to equal 180. So this is the equation we're going to solve. Combine like terms, 3x plus that 1x is 4x. We still have the minus 40. We can move that minus 40 to the other side by adding 40 to both sides. So 4x equals 220. And then we can divide both sides by 4. So x equals 55. So this picture might look a little overwhelming. My first suggestion would be to extend all the lines so that you can start to see the picture look more like something you're familiar with. So I'm going to use black too, just to make it kind of look a little bit closer to the picture. Boom. Okay, so we've got a lot going on. We actually have two pairs of parallel lines. I can see here and here, those are parallel, and I can see here and here, those are parallel. Okay, so I'm going to erase that for a sec. So we have lots of different transversals going on here. So we're going to have to take one transversal at a time and then try to ignore the rest of the picture. So we have to try to find the values of x, y, and z. So the first thing we might want to start with is look for something that you know. So I think what I'm going to start with is this transversal right here, and then this and this, and those two parallel lines, okay? And what I see is I see this 2y and this 18, and I see that those are alternate interior, which means they are congruent. So I might want to start off by setting them equal to each other. 18 equals 2y. We got to start somewhere, okay? I can solve that very easily by dividing both sides by 2, and then y equals 9. So there's one of my values right now. Now that I know that y is 9, I could go back to that 2y. Well, I already know that it equals 18, and I could write 18 there. So I could also remember that this angle right here is 18. All right, so let's see something else. Let me switch colors again and see if we can see some other relationships. All right, so let's look at that. Let's look at maybe this line as my transversal and these as my parallel lines. So I'm going to try to ignore the rest of the picture. And what I see is, let me get a different color so you can see this. I see this angle 63, and I see this angle 3x and 18 together, okay? And those two angles together with the 63 are same side interior. They're on the same side of the transversal, and they're between the two pink lines, which means they're supplementary. So they're going to add up to 180. So I'm going to do that. I'm going to say 63 plus that 3x plus that 18 equals 180. And I'm going to solve that. Anytime I can create an equation that only has one type of variable in it, I can solve for the value of that variable. So we kind of have to be creative. First, I'm going to combine that 63 and that 18. And that's going to combine to make 81, I believe. And then I'll move all those constants to the right side by subtracting 81 from both sides. So 3x equals 99, divide both sides by 3, and x equals 33. So there's the value of x. It might even be helpful to go to that angle that was 3x and do 3 times 33 to know that it's 99. So let's say 99. It goes right here. Okay? All right, let me get one more color. And we'll try to figure out this last part. All right, let's do this. So I still got to get that z, and that, so I see that 11z. It's touching that green transversal, so maybe I'll go back to that guy. So I'm going to look at this transversal, and the other line that makes 11z is this guy, which is parallel to this guy. So those are the three lines, those three orange lines. And let me get another color here. So that 11z, I can see that it is going to be alternate interior with that 3x, which we just found to be 99. So because those are alternate interior, they are congruent. So I'm going to set that 3x, or that 99, equal to that 11z. And I've got a real simple equation here to solve. We're going to divide both sides by 11, and then z also equals 9, just like y did. And that's how you do it. You kind of have to just, so first extend your lines. You might want to redraw your picture for each variable that you're solving for, and highlight, maybe just the transversal and the two lines so you can focus on it. But try to just focus on one part at a time and focus on what you know and what you can solve for most easily first. Sometimes you'll have to solve for one variable before you can solve for the other. All right, guys, I'll see you in class. Let me know what questions you have.